Hi everyone, a very warm welcome to today's webinar. My name is Apalak Ghosh, and I work with a market research and consulting firm called Cyber Media Research, and I've been associated with them for the past 7 odd years now. Prior to which, I used to work for traditional market research firms, which were more in lines with market research in the space of technology, FMCG, consumer durables, and so on and so forth. For the past 7 years, I have been an analyst with IDC, International Data Corporation, and now Cyber Media Research. And my core focus area has been technology. So today, as it is clear, I'm going to discuss about cloud computing. What is cloud computing? Why is it relevant in today's context? And what promises does it hold going forward? Right. So, just to the next slide, I'm going to cover these 7 areas. First, I'd like to introduce this topic to all of you. What is cloud? Second, evolution of cloud computing, as in every technology has an evolution path. So it leads to a certain solution. So it does not start off just out of nowhere. There were certain requirements, there were certain tectonic shifts in the business which led to a certain solution or technology getting developed. So how did the evolution of cloud computing come by is something that I'll be sharing with you. Then important characteristics of cloud. When we say this is a cloud computing solution, what is a cloud computing solution? What makes a cloud solution a cloud solution? Then there are various types of cloud computing, as we mentioned here: software as a service, platform as a service, and infrastructure as a service. So, moving on to the next slide, when we say what is cloud computing. So, and before we discuss what is cloud computing, let me give you an overview. Typically, and I think you'll be able to understand more why cloud computing is important, right? Why people want to use cloud computing, right? Now, cloud computing can be used, first of all, before we get into technical space. Computing can be used can be used by people like you, me, and our friends alike. So, which is what we call in the B2C, what is business to consumer space. And cloud computing can also be used in the B2B space, right? So, having said so, I'll give you a corollary example. So, 15, 20 years back, when our parents were planning to buy a car, buying a car was not that easy. And you might ask me why. And the fundamental reason was because, for instance, if a car was for, say, 2 lakh rupees at that point in time, they had to do the entire down payment of 2 lakh rupees because getting, you know, sanctions for a loan was not that easy, right? So doing a down payment for 2 lakh rupees was a must, post which you could have picked up a car. Now, back in those days, 2 lakh rupees was a huge amount. People hardly had that kind of money, right? So it was only the far and few and the rich only who could afford cars. Then, which is now in financial terms, it is what we call as capex, capital expenditure. One time payment, you do it and that's it. And then the product or service is yours. The other way was came the concept of EMIs, and we all know what EMIs are, right? I'm sure you would have heard about what EMI is. EMI is nothing but equal monthly investments, right? Or equated monthly investments. What did EMI? How did EMI change the entire landscape of how people started buying more and more cars? Simple. The same car which was for 2 lakh rupees, people perhaps had to give a down payment, which we do now. You give a down payment of the 10%. The 10% of 2 lakhs is what? 20,000 rupees. Now, imagine a scenario you have to give 2 lakh rupees vis-a-vis 20,000 rupees. Which is easier? Obviously, giving 20,000 rupees was easier. Following which, people could give EMIs as low as 3,000 rupees, 2,000 rupees, or 5,000 rupees, which led to more people buying cars than ever before. I think that's, for me, a great way to establish why cloud computing has become such a phenom as it is today. So, and why I give this example of cars, of down payment and EMIs, is because cloud computing, from a fundamental money transaction point of view, is it enables people like you and me, who don't have access to probably a lot of money but want to use a best in class cloud feature, software features or infrastructure features. They get to utilize the best in class software, uh, platforms or infrastructure at a fraction of cost. So, that's why the uptake of cloud computing became that much more. However, when we talk about cloud computing, what is cloud? So, cloud is nothing but an aggregation of servers, low end computers, and storage hosting solutions which run somewhere. Now, I'm sure I'll give you an example as to how you people yourselves are cloud computing users. Yes, and I mean you, all the listeners today, into this in our conference. Cloud computing as a concept is not new anymore. That I'm sure you are aware of. It's been there for a very long time. Yes, cloud computing from a enterprise business standpoint is something which is relatively newer, but having said so, cloud computing has existed for a very, very long time, and all of us are users of cloud computing. And as I mentioned, all of you, I'm sure, and I'm like 100% sure, all of you yourselves use email, right? What is an email? You typically, when you have an email, or probably on Gmail, on Google, on Yahoo Mail, or it could be, yeah, and you have hundreds of mail exchange servers these days. What do? You go to your you know you go to a browser. It could be a Google Chrome browser, it could be Internet Explorer. You type in gmail.com, the screen appears. You enter your username, you enter your password, and then you have your emails in front of you, right? Now, the beauty of typical email, right, is you can use this, access this, your Gmail right about anywhere. You can use it from your laptop, from your smartphone, from your internet parlor, at your office. So it is basically your mails are there with you anywhere and everywhere, wherever there is an internet connection, right? So that is nothing but cloud computing. So now imagine all these mails that you receive or you share, right? They're all in front of you, in front of your desktop. But imagine there must be somewhere where all this, because after all, this is data, right? Your mails are nothing but information which is being shared or taken in. But somewhere all of this gets stored, right? That is getting stored in these huge, huge data centers which are residing somewhere, which you're probably not aware. Have you ever thought your Gmail, your mailbox, basically, your mailbox, as I mentioned, is you have access on your laptop, on your desktop, on your smartphone, on when you go to internet parlor, when you go anywhere, anybody's computer, you just need your browser, your username, password, and you're on. Have you thought? So all this data, then finally resides somewhere, right? So it resides in this. Say Google has this huge data center, right? Right, where it stores all this information. So if it is like, for instance, my mailbox, so which is I have a mail account with Gmail, for instance, right? So my mail, all my mail, which I've been, and have had this for the past 20 odd years now. So all my mails which I've shared or received, right, all this data is residing with Google under very strong security parameters, right? So that is a classic example of cloud computing, right? So it can be, as I mentioned, it can be accessed via internet from anywhere from the world. It is user centric, it is task centric, it's a powerful tool, obviously, and it's programmable, right? So why? And here we mentioned user centric. So it is easier for group members to collaborate. So what are we doing right now? We are doing a webcast on Google Plus, right? Where there's a webcast where I'm speaking. All of you have come in and hearing me, and thanks for that. So this is nothing but a collaboration platform, right? And this is being possible thanks to cloud computing, right? You have logged on, and I have logged on. I am sharing my presentation. You all are on listening mode, right? And all of this is happening on a platform which is nothing but cloud computing platform, right? Where it can be used by various people, right? All you need is an internet connection, right? So that is the fundamentals of cloud computing. So if I go back typically to the traditional software, for instance, I'm sure you people, all of you have somewhere or the other in your life used MS Office. Now I'll give you the difference. Now imagine you have created a MS Word. You've used MS Word to create a document in your laptop. Now, when you want to access this document in another laptop, would it be possible? It will not be possible until unless you have shared the document through a mail to, and then it gets stored in your mailbox, and then you can access from anywhere. That's again your mail. Having said so, but typically because your MS Office, right? MS Office typically constitutes of your MS Excel, MS PowerPoint, MS Word doc, and so on and so forth, right? So typically when you create a Word doc in your laptop using MS Office, that document resides in your device, right? So that is not cloud computing, because that's a on-premise. That software resides in your device, and it can be only be accessed through your device alone. However, to give you the example of cloud computing from a vendor standpoint, Microsoft understood that people are on the go. It is always not necessary that they carry their devices everywhere that they go, but and with today's fast-paced life, they want to probably say, imagine they worked on a document yesterday, and they have a client presentation tomorrow, and they're not carrying the desktop. But for this, Microsoft came out with a solution called as Office 365. So you may wonder, what is Office 365? So Office 365 is the same Microsoft Office, the entire suite on cloud. So how does it work? So simple, like how you access your Gmail or how you're doing the collaboration right now. You go to an internet browser, right? Either an Internet Explorer or a Google Chrome. You type in office365.com. You have your username and your password, and there you go. All your documents, whichever of the one, if you are a user of Office 365, right, it is nothing but your MS Office on cloud, which basically gives you the power to work, edit, delete any document from anywhere in the world. All you need is a browser. So the Word document that you were working on yesterday on a particular device using Office 365 can be accessed by just plugging on to Office 365 from any device you want to. So that is a classic example of how cloud computing differs from, say, a traditional software. Now, typically, if you take the license, for instance, I'll give you another example. If you take again, the same example of, say, Microsoft Office, you have a one-time license. You buy that, right? You buy that, and MS Office, I'm sure, does not come cheap. So I don't know, I don't have the exact figures with me, but I'm sure it runs in thousands. Some probably 10,000, 14,000, 15,000 for a approved license MS Office suite, which resides on your desktop. But how does Office 365 work? Office 365 has the same feature set like MS Office does, but you can access your documents from anywhere and anywhere in the world, provided you have a browser. And how the pricing works is, it is pay per use. Remember these three very, very important ones. These are, I mean, I'll come to the characteristics of cloud computing, but I think these are the most fundamental piece of cloud computing, which is pay per use. So each time you log into office365.com and you access your documents and you use it to do whatever, to create a document, to edit a document, to save a document. So it is only as per your usage that Microsoft charges you. So pay-per-use models could be uh, weekly billing, monthly billing, so on and so forth. So what is happening is you're not upfront paying 10, 15,000 rupees that you had to in a traditional model. All you have to probably pay some 500, 600 rupees a month. Now imagine, isn't that awesome? Right? So that is the basic shift. Now, that is why I gave you the corollary between, say, buying cards with upfront payment of 2 lakh rupees vis-a-vis an EMI of 3,000 rupees. So you're getting the best in class software at a price which is much more affordable to you, right? And you can pay for as much as you use, right? So that's the concept of maximum utilization of the given resources available in front of you, right? Because typically what happens is you end up spending on a particular product, technology product, for instance, right? But you don't utilize as much as you wish to. So I'm sure a couple of quite a few of you are from the technology background, and you know the basics of a enterprise IT setup, right? You know what a data center is, right? A data center is basically the space where all your uh, IT hardware gets installed. You have end compute devices like your desktops and laptops. That's for for people like you and me who have access. But somewhere you have servers installed, you have storage devices installed, you have the entire networking infrastructure layer installed. In such a scenario of in such a scenario, right? Just give it a thought that we when we talk about the power of uh, cloud computing, how it impacts all of us, right? So spending so much money on, say, because a lot of people these days don't have, say, now coming from a B2B standpoint, don't have the money or the space to install say a server or a storage, right? It's expensive. So I give you an example of software as a service till now. I'm giving you an example of a infrastructure as a service. Now the same infrastructure is, for instance, you log on to a browser, you go to a website which provides you infrastructure as a service. So what is infrastructure as a service? It is nothing but, again, you have a username, you have a password, and once you're on, you can do your computing, be it graphic designing, where you need to have access to very high computing power, you need storage, and so on and so forth, right? Platforms. So all of this is possible because they provide you the same level of infrastructure, if not better, than what you would have got in a traditional data center, which constitutes of networking, server, and storage, right? So going forward, what is not cloud computing, right? So cloud computing is not just network computing. So it is not just about couple of computers connected to each other and that's about it. No, it is not about application data are not confined to any specific company's servers, right? There's no VPN access. Uh, it encompasses multiple companies, multiple servers, and multiple networks. It is not traditional outsourcing, right? No subcontracting for computing services for a specific outside firm, and not a contract to host data by third-party hosting businesses. So cloud computing, in a sense, is typically now again, I think it is important for us to understand one thing. There are two types of cloud computing also, right? Which I am not sure whether it's covered in in these slides. One is what we traditionally know as public cloud computing, the other being private cloud. So most of our discussion today is restricted to public cloud. Public cloud, as the name suggests, is open for anybody and everybody, right? Who spend a certain amount of money, get access to the solution offerings. It could be software as a service, as I mentioned, it could be infrastructure as a service or a platform as a service. Platform as a service is typically used by the developer community, people who want to work on platforms to create, who are developing on creating programs or working on testing or stuff like that. So, but private cloud is altogether different because private cloud is restricted for a specific company's requirements, right? So, what is exactly cloud computing, right? So, moving on to slide number 5, it's a style of computing where massive scalable IT-enabled capabilities are provided as a service over the network, right? So, the bottom line here is everything is as a service. You don't need to buy software, you don't need to procure the platform, or you don't need to procure the infrastructure yourself to get access. It is provisioned to you through an internet connection onto your device. And a device could be a mobile phone also, or could be a tablet also, could be desktop, could be a laptop, right? So you get access to all these amazing softwares, platforms, or infrastructure through what is called as cloud computing. Now, again, a very important uh, fact not to be missed here is when we talk about cloud computing, it is also a very big feature is scalability. Now, why I'm saying scalability? Imagine imagine. Okay, I'll give you an example which you can relate to. Right now, as you all are aware, the T20 is getting hosted in India for the first time, right? And T20 is getting hosted in India for the first time. There's a huge buzz around it. I think the first match, if I'm not mistaken, is beginning on the 8th of March. Now, there are a lot of these cricketing websites which will cover the T20 matches, right? Now, imagine a scenario wherein you go to a Crick Info, a Crick Buzz, or any of these websites. There are hundreds. There are a lot of NDTV covers it, Rediff covers it. I mean, and I'm sure ESPN covers it, Star Sport covers it, and there are millions out there. So the traffic, right? The traffic on a typical non-cricketing day, right, like today, will not be huge, right? So imagine if they were, if their infrastructure was such that right now what are they doing, right? But today probably there will be say 100 people coming into the website, right? Which is nothing but in our context, this is what we call as traffic, like people coming onto the landing onto the website, seeing what is the website and so. Because every time you land, you get access to something, right? So you are using their IT infrastructure in some form or the other. So for that is fine, but on the day of the match, because everybody wants to have the live score update. The same difference is today if there were 100 people coming onto your website and are using your website, which you were easily able to manage, on the day of the match, you might have 10 lakh people coming to your website. Imagine. Are you prepared to handle 10 lakh people? The answer might be yes or no. Yes, then there's a problem. No, then there's a problem. If yes, you are competent enough to handle 10 lakh people for your website, challenge for you is on an off-peak day, like today or tomorrow when there is no match, why would you want to spend on an infrastructure just for that 1 or 2 days of cricket match, right? Think about it. Would you rather not use cloud computing and cloud computing something what we as we described earlier, infrastructure as a service, right? So what happens is you on the day of the match, right? A Crick Info or a Crick Buzz uses infrastructure as a service from any cloud computing provider, right? It could be an Amazon, it could be a Rackspace, it could be NetMagic, it could be Reliance, it could be Tata Communication, anybody who provides infrastructure as a service. So they say, I'll have so many people coming in, so I need a lot of storage, a lot of computing, a lot of IT infrastructure as a service that you need to provide to me. So what they do is Cricinfo uses IS services only for that 1 week, 2 week, or 3 week that T20 is happening, after which they stop using it. So what is the biggest benefit? Biggest benefit was they were able to utilize maximum of their resources because they only paid for those 3 weeks for the infrastructure provided. Had they not, Had they had all of this for themselves not being utilized, they would have to pay high. It's a high involvement of money without proper utilization, right? The second piece is, imagine you don't have it. Now, if you don't have it and just suddenly there's a lot of traffic, what happens? I'm sure you must have witnessed. I witnessed it when I was in class 12 standard. I remember the CBSE board results are out, and you want to see bhai pass hue hain aise. What happens in such a scenario? Suddenly, the CBSE website gets flooded. There are millions and millions of students are flocking into the website to check what are the results. Now, if CBSE does not have the infrastructure, the bandwidth to support that, it crashes. And that is not what you want to do. That is a day of testing. You want to have a seamless experience for everybody who lands onto your website. So, in such a scenario, again, cloud computing will be very, very critical. Moving on to slide number 6, as I mentioned earlier, typically what has been the evolution of cloud computing. So this is something which has not come off suddenly. It has had a gradual evolution. So it began with what we call as grid computing. It moved to utility computing. Then it came to something called as software as a service computing. And then finally it became cloud computing. Typically, what we talk about grid computing, typically grid computing was, a combination of multiple, computers interconnecting with each other so that they could use the power of computing of, say, imagine you have computing power of X amount with one computer. The moment you connect two computers together, you get 2x amount of computing power. If there are 10 connected, you get 10x the amount of computing power. This was typically used for to solve complex problems, large data sets, right? Then it moved to utility computing. So basically, where it was, what the utility of the term means typically, for instance, so this is in a way what one of the basic tenets of cloud computing is. It is you pay for what you use. I'll give you an example. The most classic example which you and I and everyone listening here can relate to is utilities like water, utilities like energy, right? Come to your house every month or probably once in 2 months. So, to give you an example, I live in Delhi. I live in South Delhi in specific, and our electricity provider is BACS Rajdhani. So they provide me with the electricity bill every month, month on month. So they bill me whatever it is, X amount. That X amount is the amount of electricity that I have utilized, and I pay only for that. It's not a lump sum, right? It's not that you have to pay 1,000 rupees flat, whether I use it or not. I only pay for the amount of electricity that I've used or the water that I've used. So the concept of utility computing was also pretty much the same. And I think that is one of the key tenets which cloud compute took forward. So it is the concept pay per use, right? Now imagine just giving another, extending the example of electricity consumption. Now suddenly you know that I have a house and I'm having another uh, floor developed on this, and basically expanding my house. So you tell electricity board that right now you've given me certain amount of electricity input, where I need more, so they provide you more, right? But that's again a capital expenditure. However, the good part about cloud computing is you can you can allocate resources based on your requirement. So it's scalable. You want X amount, they'll give you X amount. You want X plus Y amount, they'll give you X plus Y, depending on the usability, right? So, in a nutshell, a couple of characteristics which symbolize cloud computing. Clearly, uh, it's a pay-per-use model, right? So, what user metering suggests, right? It has great accessibility because everything is browser-based. All you need is a browser or an internet connection, and you can use the most amazing software, most amazing infrastructure, or the platforms to do your stuff. Agility, because as I mentioned, it is a third party who's providing it to you. So you, for instance, and this you will be able to understand if you understood a little bit of enterprise IT. So, for instance, you know, there is a company which bags a very big, large IT project. Now, to make sure that this IT project works, they have to provision or buy more IT infrastructure. That takes time. That takes time to buy, procure, manage, upload, right? But thanks to cloud computing, which is basically what is it? It's like borrowing somebody else's huge data center, right? All you're doing is it's like uh, by going to a warehouse, right, or going to a sabzi mandi, and but that's they have resources are plenty, right, and you buy it from them. Here, what you're saying is you have such a huge data center, you already have that. All you do is provision it as per my requirement. So since they already have it, they don't need to. It doesn't take time for you to upscale it. So it gives you agility. You use flexibility. It depends on your requirement. It's got it's definitely cost effective if you know how to use it properly, right? It's automated environment, and I think a point it is not mentioned because that's one of the big concerns about cloud computing. It is very secure. Because obviously, the security of cloud computing is managed by experts, people who know it more than probably us, right? And finally, if you see, there's a concept which is mentioned here called virtualization. You know what virtualization means? So I'll try to give you it because virtualization in many ways has worked as a platform for cloud computing. So what is virtualization? So I'm sure a lot of you know what a server is. I'm sure everyone knows what a server is, right? So imagine a scenario: you have a server, right, which can do X amount of work. Say in terms of numbers, uh, there are various partitions, right? So okay, I'll give you make it easy, very much more easier. Remember those days when you still have a laptop or desktop where you do partitioning, C partition, D partition, E partition of your hard disk, right? Right, you do partitioning and then you keep your data based on that. What happens is typically in organizations, right? In large organizations, they have multiple servers. They have multiple servers, and these multiple servers are used for different purposes. So one server could be used for mailing, one could be used for collaboration, one could be used for ERP, so on and so forth. But now let's take an example. One could be used for printing, right? One server dedicated for a one single work. But most of the time, now imagine a printing server, right? Now the printing server will only be used when you're printing something, right? Otherwise, most of the time it is not utilized. But the energy used to run the server is the same because it can't be stopped, right? This energy is being used same amount, but your utilization of your server is only when you're printing. But imagine now in the server if you did partitioning. So in one server, by using the concept of virtualization, you are partitioning your server for printing, for mailing, for running a application, and so on and so forth, based on requirement. And this virtualization as a concept, so this partitioning happens dynamically. As per the requirement, server provisions this much of computing capacity based on the need, right? So, and cloud computing works on this chassis of the platform, right? So, going to slide number 8, typically the cloud computing framework is, as I mentioned, concept three layers: software as a service, platform as a service, and infrastructure as a service. And as you see here above, there's a new concept called as business process also as a service. So there are processes which are being trying to be deployed as a service to replicate the cloud model. Now, getting on to specifics of each of these areas, starting with software as a service. Typically, when we talk about software as a service, uh, You have applications such as I mentioned, word processors, CRM. So one of the uh, biggest names of customer relationship management software as a service. One of the pioneering companies which did this was a company called Salesforce.com. Right? So what did imagine a company, imagine a bank, okay, imagine a bank or any company, any manufacturing company or any sales led company, right? For whom customers are very important, right? So imagine they buy a CRM software, install it, and they use it. There's an expenditure for that, right? It is an important software, but it is not always used extensively. It is used for sales purposes only. So can we not use something like CRM, which is a software as a service, and use it only as per our requirements, right? So that's the fundamental concept of software as a service, right? So and what is required clearly is, as you can see here, that at times, for instance, your company or the company that you will eventually work, right? There are various functionings, right? Various things that are happening at your back office. So you, for instance, you already have a ERP deployed, right? Which is ERP, you know what it stands for, Enterprise Resource Planning. So you have a ERP deployed, and you already and you are trying to use software service, say like CRM, like Salesforce.com. Now Salesforce.com will have to back integrate with your ERP to get the data, right? So that backward integration is important, and somewhere software service from an enterprise grade needs a little bit of customization as per the requirement. And finally, as I mentioned, it is again a pay as you go model. Coming to platform as service, as I mentioned, it is primarily used by developer community, and so you can create applications, you can work on coding, and as you might be aware, typically these platforms are expensive, right? You need very heavy computing power to do programming or run applications, collaborate on application creation, designing, for instance. You need huge RAM, right? So all imagine all you have is a very basic computer, right, which has got nothing but an internet connection. Yeah, as basic as that. But you want to do amazing software development in that. So typically, what we have been told all these years is, for doing software development, you need to have a very high grade computer, which has got amazing computing capacity, amazing infrastructure, uh, and have the most upgraded uh, languages installed in it or platforms on it. It could be COBOL, C Sharp, Pascal, .NET framework, so on and so forth. And all of this comes as a price. But imagine all you have is a browser, and once you plug in, once you do a username password, and you get the on the browser itself, you can do the coding because your C Sharp or your .NET platform or your Java platform is already there. So you do your coding on the net itself. So that definitely works also in many ways. Finally, as I mentioned, I think I need not share too much around this because I think I've covered infrastructure as a service to a very large extent. So it is basically provisioning or borrowing infrastructure from a third party and paying for the consumption that you have done, right? So that obviously creates new opportunities to make sure that your go-to market, your or time to market is much quicker, right? So sum up, as I mentioned, a couple of examples of SaaS, PaaS, and IaaS by various vendors. Software as a service, as I mentioned, you have Salesforce.com, Google Apps also has Oracle on Demand, NetSuite. Platform as a service has, like Amazon, it was a great example, right? So that's about it. So I think I just thought I'll share some fundamentals of cloud computing. Hope it gives you a little more light in terms of what it is, what are the things that matter, right? So that's it from my end, folks. Thanks a lot for listening in. If you have any questions, please feel to feel free to ask them now. So there is in your screens you will see a small settings button, right? So once you press that settings button, what you will get is basically a question session, right? So once you press that, you will be able to ask questions to me directly. All you have to do is type in your questions, and I'll be more than happy to take them. So I give you time to access that. Go to your settings button. Once you press that, there would be uh, questions that you can ask. Write those questions down. I'll be more than happy to answer. So I'll take a minute or two to wait for your questions to come. So I don't see any questions coming in from anyone, which is fine. So anyhow, thanks for listening in. Hope it was a great session for you people, and looking forward to hearing back from you. If you have any questions, do drop in a note to the Kawil team. We'll be more than happy to answer. Thank you so much. Have a wonderful day. Have a great weekend ahead. All the best for your careers. All the best for everything. Thanks. Bye.